Welcome to Lesson 2 on gas laws. Our lesson objectives: determine the number of particles of a substance using Avogadro's law, determine the relationship between pressure versus volume, volume versus temperature, and pressure versus temperature, and lastly, identify the diffusion rate of gases. Avogadro's law states that equal volumes of different gases at the same temperature and pressure contain equal numbers of particles. What does that mean? It means that if you have the same conditions, meaning the same temperature and the same pressure, it does not matter what gas you would have the same number of particles. So in this example here, we have the same temperature at 273 Kelvin, the same pressure, and therefore the same number of particles of gas, even though one is neon and one is xenon. So it doesn't matter the type of gas that I have, we would have the same number of particles. They would occupy the same amount of space. So here's an example. At the same temperature and pressure, which sample contains the same number of moles of particles as 1 liter of oxygen? So again, Avogadro's law states that we want the same conditions, the same temperature, pressure, and volume. And so, in this case, we're looking at 1 liter of oxygen. So we're looking here for the same conditions. So we're looking for 1 liter of any gas. So the liquid is out. The top three here, A, B, and C, are gases, but the only one that has the same conditions is going to be choice A, which is 1 liter of neon. So the same volume, and therefore the same temperature and pressure, would give us the same number of particles. Let's check your understanding. Can you determine the number of particles of a substance using Avogadro's law? Now let's look at our gas laws. There are going to be 3 gas laws we're going to look at. The first one is going to be the relationship between pressure and volume. It's called Boyle's law, but we do not need to remember the name. In Boyle's law, this pressure versus volume, we have an inverse relationship, meaning as the pressure on a gas increases, the volume, the amount of space of the gas is going to decrease. And so our inverse graph is going to look like this. Increasing pressure, we see decrease in volume. And we can see that here as well. As we increase from low pressure to high pressure, you can see the amount of space that we have is going to decrease. The next relationship we have is volume versus temperature, or temperature versus volume. This is called Charles' law. And in Charles' law, when the temperature of a gas increases, the volume also increases if the pressure is held constant. This is a direct relationship, as you can see here in this graph. So we're increasing temperature, and we see the volume is increasing. You can also see that here in this model here, as we increase temperature on our gas, we can see that the volume of our chamber has increased. And our last gas law is the Gay-Lussac's law. This is looking at pressure versus temperature. This is also a direct relationship. So when temperature of a gas increases, the pressure increases at a constant volume. So our direct relationship graph looks like this. Increasing temperature, we get an increase in pressure. And we can see here the reason why is as we increase temperature, we increase kinetic energy. And so as these particles are moving faster, indicated by the longer arrows here, as they're moving faster, they have more collisions and more forceful collisions with the sides of the container and each other, which therefore in turn is an increase in pressure on that container. So summing it up, if temperature is a variable, so if temperature is involved, then the relationship is direct. So temperature versus volume and temperature versus pressure is a direct relationship. So when one goes up, the other one goes up. If temperature is not a variable, if that's held constant, then the relationship is inverse. And that example was pressure versus volume. Let's check your understanding. Determine the relationship between pressure versus volume, volume versus temperature, and pressure versus temperature. Now let's look at Graham's law of diffusion. Graham's law of diffusion states that gases move from a higher concentration to a lower concentration, and that lighter gases will diffuse the fastest. And so you can see in this animation, we pop the top, we have a high concentration here, low outside, and so the gas particles are going to spread out to the lower concentration until we reach equilibrium. Looking at an example, which diffuses the fastest? So which gas is going to diffuse the fastest? We have helium or we have nitrogen. Well, we said that the lighter gases will diffuse the fastest, and so helium has a mass of 4, where the molecule of nitrogen here has a mass of 28. So helium's our lighter gas, and so that's going to diffuse the fastest. Let's check your understanding. Identify the diffusion rates of gases. At this point, you should be able to determine the number of particles of a substance using Avogadro's law, determine the relationship between pressure versus volume, volume versus temperature, and pressure versus temperature, and identify the diffusion rates of gases.